Ну что, уважаемые коллеги, поскольку мы все есть и
Distinguished colleagues, considering that we are all here,
ударили полночь, но полночь не
and
означает
I should say that it is the high
примерно
time
полночь
for us
сейчас,
to
это
start.
по-Камчатски.
So it is
Тем не
just the
менее, мы
right time for us
начинаем
to
с вами
start,
нашу конференцию
and
«Цифровизация
it's
верфей и аддитивной
2 p.m.
интеграции в
sharp.
современном
So we
судостроении».
are starting our
Очень приятно
conference,
видеть полный зал, потому что
Digitalization in Shipyards and Additive Technologies in Modern Shipbuilding. It's an international conference, and the topic is really exciting. I very much hope that today we are going to learn a lot of new and useful things. Therefore, basically, we are having these conferences. I would like now to urge the speakers to stick to the schedule and allocate for their speeches no longer than 10 minutes so that we have some time for questions. But if we see that we are beyond the agenda, then no Q&A. Q&A is going to be on the margins. Well, as our agenda says, I'm supposed to give the floor to the first speaker, Georgiou Papadimitriou from the Singapore Maritzat, the sales director for Europe. And colleagues, if you need simultaneous interpretation, we have simultaneous interpretation arranged, so please enjoy. Mr. Papadimitriou, the floor is yours. Where's George? George, you are ready. Excellent. Excellent.
So, thank you very much for having us today, presenting about this topic. And this is a great opportunity for us to showcase some achievements we have done. The topic today is the digitalization and the vessel communications, let's say, in the new artificial intelligent era. I would like to have from you the remote. Sorry. Thanks so much. So as I said, we see communications and information technology as a whole, which has to be served by a satellite service provider and information technology service provider in the AI era. And please let me show you a video of this new era, which is actually today, as we have developed the tools to implement the new communications and IT information, the new environment for the vessels. Can you please play the video?
With innovative technologies like broadband satellite, artificial intelligence, edge computing, and big data, the Smart Ship Management System enables the ship company to get real-time operating information and safety status of the vessel to improve working efficiency and vessel safety. Based on customized AI algorithm and edge computing, MarineSat Vessel AI CCTV system effectively helps ship and shore improve the safety management by precisely identifying pilot boarding, illegal entry, abnormal seams, obstacles and various safety auxiliary applications like ranging at port and so on. By using broadband satellite, 5G, and IoT technologies, MarineSat Freezer Link System assists consigners to be aware of real-time information like temperature, humidity, location, and displacement detected during the whole route, from ex-workshop until delivery, to ensure the safety and quality of the cargo, regardless of the geographic factors. Applying with 5G and AR technologies, MarineSat effectively solves difficulties of ship visiting caused by frequent policy change, lack of manpower, high traveling costs, etc. MarineSat Cloud Ship Visit System enables remote standardized ship visiting and automatically saves visiting record to establish a standard database of ship management. Bundled with OCR intelligent recognition and SaaS hybrid cloud, just by one click, crew can use MarineSat Smart Ship Office System for spare parts application, or in an X warehouse, enabling superintendent master the safe inventory and spare parts boarding process, realizing mobile vessel information management. The AR Glasses remote maintenance system and VR Glasses crew training system help the crew have a deep comprehension of various field troubles quickly to improve crew's capabilities and carry out the ship maintenance work more efficiently. The ultra-broadband hybrid satellite solution shifts the vessel from information-isolated island to all-media crew application era, enabling crew members to keep in touch with their family via voice and video calls, interact in social media, and be involved in social activities. Healthcare of seafarers is also one of the most critical concerns of the shipping company. By using broadband satellite, AI, and telemedicine technologies, seafarers are entitled with high-quality and timely remote medical services to relieve the shipping company from the worry. Efficient, user-friendly, and safe information management tools help shipping company to gain trust of consigners and win in the competition. The era of AI vessel information management enables all shipping practitioners to break the geographical restrictions between land and sea, which makes work simpler and safer for crew members, and more efficient and easier for personnel ashore as well. MarineSat Smart Maritime Service Platform.
So after this informative video,
Я надеюсь, что этот видеофрагмент был достаточно информативным. Теперь я хотел бы сказать несколько слов о нашей компании, компании MarineSat. Наша компания была основана в 2014 году. Сначала она была филиалом компании Sunwave Communication.
a public company. It is public in the Shenzhen Stock Exchange. We are we are the business unit of Sunwave Communications, the satellite service provider, the larger actually in Asia, and we are in the top 10 list of VSAT satellite provider worldwide. We are also well known in China for our smart applications, and our headquarters specifically are in Hangzhou region. We have a global operations centers. Our overseas center is in Singapore, and we have also European operations center in Greece. I am actually based in Greece, supporting sales and marketing of our company in the European continent and Russia. Our NOCs are spread globally in Hong Kong, in Malaysia, in Japan, in United Arab Emirates, New Zealand, and Indonesia. So we are expanding globally, and we can support our global customers everywhere, so we can support internet on board the vessels everywhere in the globe. Let's talk a little bit about our products and services. First of all, we have to build, and we build a reliable satellite link on board the vessels. We buy capacity from our suppliers, and we build up specific packages for the merchant maritime companies. We base our service in the iDirect Velocity platform, which is now at the edge of the technology, supporting maritime communications all over the globe. And we collect satellite beams from 52 plus satellites, either high throughput satellites or wide beam traditional satellites. We also we adapt our packages in information technology and communication services. We use Internet of Things technology, and in order to provide business communication to the vessel and crew welfare to the crew members, which is utmost important. So we support multiple satellites for key routes and for the dense areas. All these packages and services are based on reliable hardware, different types of hardware, starting from 65 centimeters diameter to 1 meter, or flat panels, depending on the networks, on the different networks, either geostatic or low Earth orbit. And we offer these as a free leasing, as we call it, so rental, on a rental commitment for our customers. So the spare parts and warranty is there to support through the life of the contract commitment. And we have reliable after-sales service team, always available 24/7 to support our customers. The advantages of our satellite network: over-sufficient, I would say, bandwidth resources and capacity to cater for seamless satellite network coverage globally, adopting the latest generation of iDirect technology, as I said previously, multiple satellites available for key routes, multiple layers, ensuring that all geographic regions can be covered by at least 2 satellites at the same time. And last but not least, 24/7 after-sales service, remote maintenance, and quick response by our project managers dedicated to support any and each one of our customers. Next, we provide value-added services. So we utilize the satellite link, and at the top, I have listed today the CCTV backhaul monitoring system. So we install cameras on board the vessel in order to provide viewing experience to the designated person ashore at the shipping company office. These cameras can also support remote maintenance, so the crew can be guided appropriately by using our CCTV remote monitoring system. The enhanced version, which is now available, is the security monitoring system. So we have implemented specific algorithms based on AI characteristics in order to recognize break-in identification or to recognize faces if a crew must be present and they are not present, so the company ashore will be notified by a short message. If someone falls on board and we have an accident, then we have a notification to be transferred to the safety department of the shipping company. So we have enhanced our CCTV remote system to be offered with artificial intelligence characteristics. At the heart of our, at the center of our system is the Smart Maritime Platform, which supports the intelligent communication link switchover. So if a vessel is provided by VSAT and backup system, the Smart Maritime Platform recognizes when the VSAT signal is low and switches over automatically to the second system, to the backup system. We provide also Fleet Communication Management Platform, Fleet IT Management Platform, and also we support IT services to be applied specific settings for the vessels to each one of the computers just by syncing at once. So the same settings to be applied to all vessels of the fleet. We maintain a copy of these settings in our data center to be always available and to be retrieved and applied to the vessels. We offer VPN connectivity, crew entertainment platform, crew welfare, and also ship-to-shore data with one-click sharing. This is the module that supports the IT manager, acts as an IT manager of the vessel, of the ship. So it applies specific software updates to the applications and on the PCs of the business local area network of the vessel, and we also do the IT management for the whole fleet. It includes also very important cybersecurity module, and as I said earlier, it maintains a copy of the IT infrastructure of the ship into the cloud. So we have visual identification of applications that need to be upgraded or up to date, so to be operated up to date, and we apply the software updates. So we have also a standby team 24/7 to support this IT functionality. And the cybersecurity system that we provide is also can be certified by the requirements of the classification societies. Another application is the Smart Ship Office, which is a new generation of an intelligent spare part management system, including into the functionality, the purchase and supplier management, the ship spare management, crew management, and material management. And last but not least, we have the ships 3D digital twins. We send a certified MarineSat engineer to record and to prepare a digital model of the entire ship, which is then available into the ship digital library and can be utilized by providing remote assistance to the crew in order to do specific maintenance work. So our message for today is that our company, MarineSat, enables the smart connectivity on board the vessel. So enable the application of new technologies of the IT infrastructure, and we offer enhanced connectivity, smart vessels applications, data management, Internet of Things, and artificial intelligence technology, which is greatly improving the efficiency and opens the development route for the ship industry by bringing more opportunities. So we are here to support any needs of digitalization of the maritime industry and the shipping companies.
Thank you, George.
Thank you very much.
Дорогие коллеги, вопросы? Any questions, if anybody have? Yeah.
Алексей, меня зовут, компания Nordic Engineering. Какая окупаемость этой системы, вот, финансово-экономическая выгода? Потому что мы...
В микрофон, иначе не переведут.
Какая экономическая выгода от этой
What
системы?
is the economic efficiency for this system? And what is the prime cost, well, the capex that need to be invested? And what is the payback period for this system?
So there is no capex actually, because all the system is offered on a rental basis. So the shipping company pays a monthly fee, including everything, all hardware and the service. It's on a very affordable basis, the monthly fee, and since there is no capex, I cannot answer the second question, which is the return on investment. So you invest on a monthly modest fee, and we undertake everything. So the warranty and of the hardware is on us, and we provide you this support throughout the contract. The contract, the usual contract period is 3 years.
Thank you once more, George. Because of a little bit out of time. В смысле, мы с вами уже из графика
We are
выходим.
running a bit of time. I won't ask for any other questions, and we will go over to the next speaker, Mr. Mikhail Druzhinin, expert analyst representing the company Nanosoft Development. He'll be talking about the automation of measurements in the shipbuilding industry.
Left side for you.
Добрый день, коллеги.
Good afternoon, dear colleagues. Indeed, I represent the Nanosoft Development Company. I would like to present you the future model that we are developing as we speak. We've been working on it for several years, and I hope that this model will be of great use in the nearest future, not only in the shipbuilding industry, but across many industries. This module titled Measurement Science or Measurements has one goal. For everything to be constructed correctly. I know that United Shipbuilding Corporation has a big project, metrics, and our software that is titled metrology or measurements will be of great use. This software is based on a NanoCAD platform. This platform is well known by many. It replaces successfully different CAD systems, including AutoCAD system. And it's fair to say that NanoCAD has a large number of functions versus AutoCAD. What's the main difference of our system? As different from other international software companies, we don't buy separate modules to integrate them. No, we cooperate directly with the developers for them to use our platform, and thanks to that platform, the developers can come up with their own modules. And when there is a great will from both parts, we join our efforts, and those independent developers become a part of our company. We have a lot of modules within NanoCAD, so-called vertical software that ensures 3D modeling, design, conception, and many, many other features. What's the main purpose of the metrology project? Up till today, there's no one single metrology software that would allow the use of project data, that would allow also to overlap measurements from different measurement devices. There are separate softwares that work with KIM, for example. But a universal software doesn't yet exist. There are foreign software of this kind, but on one hand we have this import substitution mission. Moreover, in some industries, like in the military construction, it's particularly important to use domestic software, this being one of our goals. We hope that almost any tool that would allow to measure something will be one day connected to our platform. Even now, any measurement device, once it has measured something, the results can be populated and inserted into our system and then treated accordingly. Our main goal is to make this process a real-time one, in order to be able to immediately use in parallel not one measurement device, but several measurement devices, just as the best international solutions do. We use almost all formats that use 3D models and grid models. In terms of the cloud of points, we are limited with 4 billion of measurements. It's quite a nice value for laser scanning. But in the nearest future, we will do an update, and we will deploy a database-based system, thus overcoming this limitation. And we will be able to do almost an infinite number of measurement. This is actually the main goal. I'm sorry, let me scroll back. Yeah, this is actually the main goal. Here you have a device. Here you have a guy, and he measures something, or he places some information on the hull. He works with a projector. The overall ship's design is uploaded in the memory of the tracker. And our operator has a little device, and he looks at this device and sees whether he positions correctly or not correctly his markings for the future support or for the future piece of equipment that should be installed at this place. It's one of the most important goal during ship construction is to overlap correctly different components and to place smaller details in the right places on top, or basically on top of the larger details. So this assembly is one of the main goal in the measurement of the large scale models, the comparison between the CAD model and the reality. We know how to set up the automatic check. If there is a modification in one place, one button click is enough for our measurement system to remeasure the entire piece, the entire points array, to know should anything else be modified. And of course it works with building berths, with stocks. This is what our system looks like. Once again, it's a tachyometer. Here you see the model that operates, and immediately we see the information about the coordinates that we receive from the device. Moreover, we can guide this device. Using the feedback feature, we can orient the device. There's another function when this device can automatically find the right spot for the next piece of equipment to be installed, so for the next support to be welded on. Another function that we have, we will come up with a mobile solution, which means you can put your smartphone in the pocket, you can go far away from the measurement device, but you will still have all necessary measurements on the palm of your hand. And all the measurements will be done in the right place, even when a worker is far from the measurement device itself. Now, using the point cloud, we can automatically define all surfaces, including pipelines and pipes of different sizes, of different curvatures. We can coincide the point cloud with the model to receive the information about the deviations. You see, every point has different color, and this color corresponds to the current deviation. So it's higher than required, lower than required, dispositioned in some way. We can verify the evenness, the levelness when you need to connect two pipes using the color. And of course, the results, it's not just a piece of paper or a file with all necessary information. But in the future, we hope that our software would be certified to define the product lifecycle, so-called the PLM, product lifecycle management. The management of point cloud is not a separate module. It's integrated within the platform, which means that all vertical modules that we have, they can easily make use of the point clouds. Specifically, this is the example when we can use it for reverse engineering. We have a piece that we need to recreate. It's very easy to do. Our main advantage is that our team has many hands. Our developers, our coders are very strong. We have our support services located in different cities of Russia, including St. Petersburg, and we have our guys in the room right now. And if necessary for every client, we can come up with not only a simple set of modules, but a working space that would satisfy all requirements from this specific client. I talked already about the infinite database of measurement. Well, this concludes my part. Thank you for your attention. I can take one question from the audience, colleagues. I have time for one question. Yeah, I see the hand. Good afternoon. My name is Artyom Sen-CZ. This is what I do. Do you have the stable version of your software? The first version will be launched in the end of 2023. Fantastic. Second short question, if I may. While you process scanning data, do you think that you can use AI as an algorithm to help reverse engineer things? If we scan a sphere, for instance, based on previous work, will your software be able to construct that? We have it. We have it. We don't. It's not actually AI. We have a lot of algorithm to treat data. We define surfaces. We can define cylinder surfaces and the junctions between cylinder surfaces between two spheres. It's the simplest way, actually. It's not AI per se. It's an algorithm-based solution. Yeah, we have it. We have it like Leica has. We have it. The solution of this particular company is not particularly a good one. I've dived deep into that. But they use rough tools. It's not a rough solution if we take into account the precision that we need to have when we do the measurements. Thank you. Thank you. This answers my question. Thank you once again, Mikhail. And without further ado, I'd like to give the floor to Sergei Korolev from Khabarovsk Shipyard Joystick Company. You have the floor. It's not a presentation, just a little message. I'll try to bring us back to the agenda time-wise. Khabarovsk Shipyard, I'm the chief engineer of it. This year we've celebrated 17th our anniversary. We are not the youngest and not the most modern enterprise. Last year, the Secretary of the Security Council of Russia, Mr. Patrushev, visited us. He saw our capacities and he defined that our venue should be modernized. So now the government of our region studies the digitalization experience of the Onega shipyard in order to apply the same experience on our factory. So the government actively started working that. We have the decree of the Ministry of Industry that created a working group bringing together a lot of stakeholders from academia and the industry. This commission held several meetings, both online and offline. I came to Moscow, St. Petersburg. What's the result? The digitalization project of any shipyard should be split into two parts. The beginning of the project is clear, and we're not even talking about financing. So we cannot do any capex things, and we cannot even plan them. Therefore, we recently agreed that we would split this project into two parts. We'll forget for time being about the capital construction, and we will transmit the technology of the pass-through construction preparation together with the St. Petersburg State Maritime Technical University. And we are creating our new orders portfolio. We don't have a lot of technologists and constructors, but we would like invite specialists, invite students. This Zvezda, if I'm not wrong, is implementing this end-to-end technology project, and we are ready to become a platform in order to retransmit those technologies at the Russian Far East. All in all, this concludes my part.
Sergey, thank you so much for saving up time. And now we are indeed back to our schedule. We are in time. Those who have not yet dived into that project, the project on profound modernization of the Onega plant is both a technological and digital project. What Sergey said, well, we understand that this is like palliative care, because if you apply contemporary digital technologies to the heat-cutting machine Crystal, it's like, having revamped the Coliseum. I think that this heat-cutting machine was designed when I was in the nursery. This is not just digital, that's not digitization. If we start a digital transformation, then we should transform everything. We should profoundly revamp all the technologies, otherwise nothing is going to happen. So there is no idea in tech modernization if it is not integrated with digital technologies, because doing that later would be not reasonable. I would like now to give the floor to Alexei Lips, who is into the digitization of the Onega plant. What is digitization? Well, let's agree on the fact that digitization is a re-engineering of business and tech projects and best world practices. Then it's going to be clear for us what we are waiting for. We are waiting for changes, including changes in the business functioning of the company. We would like to benefit from the opportunities that new technologies open up in terms of introducing some kind of changes, rather than automation. To have this process there, we need the so-called digital maturity of all the stakeholders. What we need is that the client understands what to expect from digital technologies. What should we pursue? And the task of the university is to establish this digital maturity, which is training, lifelong training, requalification of professionals. This is what we have been doing from the last century. And we are into that year to year. We are opening up new professional areas in fields for training. Today, the university provides professional training in cognitive production, additive production, digital production. That's one thing. That's the prerequisite and collateral number one. On the other hand, we need specific tools that would allow us to resolve these issues. And today we are confronted with the so-called situation which is called import substitution. This is an inaccurate term because the domestic Russian school of design, of ship design, would rather be more happy with the term advanced import substitution or import advancement, import over performance. Over the last few years, we have been actively engaged into substituting foreign-made IT technologies with Russian-manufactured IT technologies, and we are very grateful to those who are here today and who invested a lot into that. I would like to extend my gratitude to those experts who were able to confront their solutions to the international software solutions and are battling for every consumer in order to resolve the issue of digital transformation. First and foremost, we need governmental public support. The government understands how dreary the situation is, and therefore the Minister of Digitalization is there to support innovative projects in this area. The first most logical step would be to enhance and finalize the existing solutions. That's number one. So we are now trying to collect everything that we have and to build something of state-of-the-art that would satisfy with the demands of digital transformation at contemporary enterprises. And today, at the exhibition, were we able to identify such a solution within the framework of one of the program established by the Ministry of Digital Development, and this is the transformation of the shipbuilding plant, the Onega shipbuilding plant. It was developed by the Maritime Technical University in partnership with Business Technology, Ascona, and many other companies. Next year, according to our plans, we shall start commercial operation of this system. Therefore, today, I believe we can perform digital transformation using Russian-made software only, considering that those are finalized and well-tested. Another factor is import outperforming technologies. Those are the technologies that are to be there on the market in 5 to 7 years and ensure competitiveness with the global twin technologies. What is the most important here and what is the huge problem? This is absence of clientele that has been using digital technologies in their routine activity for quite a long. Therefore, we will have to simulate that in order to assure of our digital maturity. Such project is being now underway and is coordinated by AFRIT. This project is about establishing automated Russian-made systems, design systems for shipbuilding, so that in 5 to 6 years, this equipment could not only substitute equipment made in other countries, but to continue the transformation and advancement, which means that it should become a tool, an instrument of digital transformation. And therefore, this year was just a definitive year, a determining year for production and development. Today, we saw the presentation of our colleague who demonstrated why are we doing that to enhance the operation and management of a vessel. Today, we had a very exciting formula, a very exciting wording that's a digital twin. It's just an exciting term, and it's absolutely clear that today we need to ensure digital continuity in our solutions. We need to ensure an integral, universal environment for continuous, non-intermittent, and seamless data exchange. We believe that the rate at which we are pacing jointly with the developers allows us to be confident about the future, and we are absolutely sure that not only would we be able to overcome the current challenges, but also would we be able to provide our shipbuilding industry with cutting-edge, top-notch digital equipment and capacities. Thank you very much, Alexei. Colleagues, if you have questions, please, one question is allowed. Well, considering that I do not see those who would like to ask a question, let's consider that everyone has digested the presentation, and I would like now to give the floor to another speaker. This is Marcos de Monte, the president of the shipbuilding industry of Argentina. The correct name would be Federación Industria Naval de Argentina.
You're welcome, Marcos. Уважаемый организатор... Нет, это прекрасно, но это не Маркос.
Well, that's great, but that's not Marcos. Distinguished organizers. So what's going on with communication? Is Marcos together with us?
Не отвечает.
Not responding.
Can you hear me?
Oh. Fine. You're welcome. It's time for your presentation, Marcos. Well, it works. Please try again.
our shipyard, and different technologies we are implementing or developing at this time. Just to make a brief explanation in the areas we are working, on the shipyard, the manpower, it's very important. We are very manpower demanding activity, but no matter that, we also are implementing a lot of digital transformation and cutting edge technologies in order to be able to increase our efficiency and production. That is being a very, very useful tool. And we have different aspects in where we are working. It includes from the beginning of the process until up to the end and where the vessel it's operating. The first stage is the design of virtual model, what we call the digital twins. We have a lot of technologies. I'm going to show you one example and how it's increasing our customer satisfaction and reducing time in the production line. Then we are also developing software to interact and to show our customers how the production is running, the quality, everything is showing there. I have an example also. Then we are working with the cloud-based technologies and cybersecurity. It is very important to be very careful with the information and how we protect that data. That is going to be one of the key investments in those days. Other important thing that we are implementing is how we measure the efficiency in our production. So the indicators on how the production is running, how we are performing, everything is in there to be able to take the right decisions, and everything pointed to reduce once again, the production time and quality. Energy efficiency and safe environment are being very, very important too. And again, the technology it's really involved in those areas too in order to improve our quality. Let's go into show you the first example and how we are using the virtual reality applied to design. This is an actual model. It's a ship we are building right now. It's a trawler for shrimps. In this area, we have the meetings, the initial meetings with the customer. Then we make the initial design of the ship based on the requirements, and then we create the model you are able to see there. This is an image only, but we can use the virtual reality, for example, using the VR lenses. And one of the main advantages of this is that the customer can actually get into the ship before it's even been constructed. So you can walk into the ship, walk into the machine area, on the bridge, everywhere. So the operator can see how for example, the visibility of the ship, of the bridge is going to be, how the operation is going to be. So you can actually see how the fishing operation is going to be. So you are able to place the different equipments on the area that are more safe or more useful. So it's a very, very good tool in the design. And this is reducing in a large quantity of time on the production line, because what we have seen in the past is sometimes it's very difficult for some customer to identify in a paper where everything is. And then when you can walk through your ship, where you can get involved into the design, it's a very, very useful, again, to reduce the production time, because you are able to start production and know where everything is going to be, that the customer is going to be satisfied. So it's going to be a great, great tool in the design. Going into the next step, where is not only the design, but the production line, what we have developed in our shipyard is a software that is like a portal for our customers, where you can see almost online how the production it's going on. So you can follow the purchasing process, the quality of the different quality testing, the progress of the construction itself, the suppliers that are working. So you can follow up everything that is on the production line. You can also, the system can also interface with different accounting and management systems. And obviously the customers, no matter where they are, here in our shipyard in Argentina, we have customers from the region that includes other customers in Paraguay, Uruguay, different countries in the area, and they can access, no matter where they are, they can access the information that we are processing and under construction in our shipyard. Just to show you a few screenshots, you can see, for example, in the first one, how the construction is evolving, the different percentage on the financing point of view from the physical advance of the construction, how the different purchasing of the equipment, steel or the different components we are using on the ship. Then you can see the structure. For example, in the bottom left, there is a picture of how the structure is being built. Then the quality reports are uploaded over there in the software. So everything is shown and the customer can follow up, as I told you, almost in real time how the production is evolving in the shipyard. So it's a very good tool for the customers because they obviously have the technical assistant and engineers in our facility, but with this software they can have, for example, the accounting or the purchasing of the customer involved in the project without being physically in our shipyard. And another stage of the production is the condition-based monitoring in the vessels. This is one thing that we are already implementing in the industrial environment, but we are now working to implement the same thing on the ships. Basically, the idea here is to create like a digital twin where the operator or the user can have all the information on how the machines are performing on the ship, transmit that data using satellite technologies, and from the central offices of the owner of the ship, the data can be analyzed, or anywhere in the world where the technicians or the specialist people is located. Basically, for example, this is the first picture is a system on how it works in an industrial environment. We have different sensors that can be analyzed with a cell phone or a handheld device, or the information can be uploaded into the cloud, and then you can analyze the data from anywhere, as I told you, anywhere in the world. The same idea is to be developed for the ships. Well, all the information and the data can be collected and transmitted. That data can be like vibrations on the machines, oil analysis, ultrasound, the power that the motor, main motor is transmitting. So that information can be uploaded into the cloud, and the technicians can analyze real time how the vessel is performing. And in case of any event, there is like email or messaging transmitting. So the technician can analyze the data and see if there is any problem on the ship and how it's performing. That it's also very, very good for creating a digital twin to train the technical people. So, for example, if you are having any issue in a pump or any specific machine on the vessel, you can show on the digital twin to the people that it's on board how to perform the activity to solve the issue. So it's a great, great tool to be implemented on the ships. So basically, I don't want to extend very much in my presentation, but I would like to show you in different stages from the very beginning on the design of the ship, when the ship is in production, how we can implement different digital techniques, and also when the ship is under operation, how we can also implement the technology in our everyday tasks to make them easier and more efficient from different point of view. So thank you very much for your time. If there is any question, I'm open to them.
Thank you, Marcus. Коллеги, есть ли вопросы?
Do we have any questions to Marcus? I can take one question.
Есть ли руки?
I don't see any hands in the audience.
Very interesting presentation. А мы переходим с
And
вами
now we will go over to the next presentation.
буквально часа не прошло, как мы подписали соглашение с регистром.
We recently signed an agreement with the Russian Maritime Register of Shipping.
На первый я приглашаю
And I would like to give the floor to Mr. Vladimir Okunev, senior expert of the Research and Development Department at the Russian Maritime Register of Shipping. He will be talking about the use of digital twins, mentioned by Marcus, while examining ships' designs. Over to you, Mr. Okunev. Thank you for providing me with this opportunity to deliver my presentation. It's a bit complicated after previous speakers to present, and there are different definitions of digital twins, which is indeed true. Discussing the topic of digitalization in modern shipbuilding, we should pay greater attention at digital twins of ships and components. And when we talk about ships design, this stage also includes the analysis of ships designs by the classifying society. Let's take a look at the definition of the digital twin. Digital twin is a digital model that has two senses of connection with the physical object. There's a certain discrepancy of definitions. One sources highlight that information connections should be mandatory in both senses, and the data transfer should be guaranteed automatically. And the emphasis is put on the word twin. And like in life, the twins are not born at the same time. So in the case of the digital twin, the digital model is created, and based on this model, the physical object is created. Other literature highlights that the information connection is not mandatory, and the creation of a digital twin is possible at different stages, which means for existing or products or for the products that are being developed. I will not dwell upon the correctiveness of a definition, but I'll be talking about the digital twin being born for the newly developed items. As for today, when we analyze the project, a digital twins element is used, the computer model or the digital model, as it is called sometimes. And for us to understand what we are talking about and to use the same language, the digital model is the system that is composed from mathematical computer models, as well as digital documents and items that describe the structure, the functions, and the behavior of the item. Mathematical model has the information about the item based on the mathematical language. And the computer model is the model that has been created using computer software. In the shipbuilding, often we think of 3D models when we talk about computer models. As it was mentioned before, the digital twin or several components of the digital twin can be used at any stage of the product life cycle. And we'll be talking about design, manufacturing, and utilization, which means 3 stages. Digital twins can be used differently. At the design stage, the digital model as a part of the digital twin can be used to verify and confirm technical solutions that have been adopted, as well as to model different exploitation conditions. At the manufacturing stage, digital models can be used to develop production technologies and to test and to create management programs for working tools with digital management. It can use also to verify the compliance of the manufactured products. At the utilization stage, digital twin can use to control the state or to manage the physical item. Digital twins can also be highly efficient when we repair or modernize the items. Coming back to the utilization of computer models, when we analyze ship designs, there are advantages. Less people are needed for development of schemes and plans, and for in practice, there is an experience. The models are seen while classifying ships. It will allow to cut 10 to 15% of the necessary labor force. Domestically, when we talk about documentation development, when designs should comply with the rules and regulations, the labor force will be even further decreased. Less labor is required to modify the designs using the overall model when all stages are performed within one model, accessible to all stakeholders. The time of the modification between the modification introduction and the production becomes shorter. So the information is copied from the model into the future drawing. This can create mistakes due to human factors, which brings to the discrepancy between the drawing and the model because of the changes that were not taken into consideration. Applying the unified model concept, when the model is the prime source of information, we can expect the high accuracy between the computer model and the physical object that brings, in the end, the creation of the digital twin. The use of model while analyzing projects will allow to use model while certifying ships when it is done remotely using drones or submersibles. When they are used together with the software, it is possible in the automated mode to compare the model and the physical item. Therefore, we can see damages, deformations, or any other deviation between the physical model and the computer model. We can measure thickness of a hull using software Ocean, allow to keep track of the use of the hull. The control of solidity of the hull can control punctual charges. Models can be used to implement rearmament project. Taking into account all advantages of computer models, the register applies all necessary efforts to develop this activity. As for now, projects are analyzed using in parallel 2D models and computer models, and we are waiting for procedures and rules to be ready in order to comprehensively utilize models. As it was said, the international practice knows the use of models during project analysis. It was done only for the whole, cooperating with design bureaus that had developed the models. The register works hand in hand with design bureaus as well. And as for now, while examining the model, we will use the software which was used for the creation of this model. Different from our international colleagues, we plan to analyze the model comprehensively, like electrical, propulsive, hull, mechanical, and so on and so forth. To completely implement and switch from 2D to 3D, several tasks should be solved. The development of the procedure of the model analysis, development of the procedure to record the results of the analysis, the development of the procedure of data transfer and modification, development of procedure of keeping track of modifications that are introduced, as well as the development of software to work with the models within different formats that had been developed using different software. The majority of tasks is housekeeping ones. And for the fifth item, this item should not be implemented right now. It's a future-oriented item. So for time being, we can use the software that was used to develop the model, which means in the midterm, 4 out of 5 tasks can be implemented. Wrapping up my presentation, I would like to say that the use of model to analyze a ship's model has advantages versus conventional approach. We see that it's future-oriented. This is why the register want to use more of digital models. The use of digital models during the project permits to develop better digital twins. In order to be able to completely use digital twins, we need to solve several issues that are being taken care of by the register. Thank you for your attention. I'm ready to take your questions. Thank you, Vladimir Alexandrovich. Do we have any questions, colleagues, about the use of digital twins at the stage of the approbation and the commissioning? Yeah, wait for the mic, wait for the mic. Alexei from Nordic Engineering. If the design bureau will come to you today with a suggestion of tools, do you have to accept? Can we initiate the process? Yes, the possibility is here. We cooperate with design bureaus, as I said already. We will perform the work in parallel, so we will use 2D drawings and 3D models to have a common approach. But these are issues related to the procedure. We stamp the drawings right now, but how can we validate digital drawings and keep track of changes? So it's possible. There are several options. Colleagues, I saw a hand somewhere from the middle of the room. Admiralty Shipyard. So I have a question. When we create the model changes depending on because components can change. The organization of the room can change as well. How will you treat this question? Because once the model is approved, the model itself can change. Because while the model is creating, it's like a living creature that changes. Something happens with it, and so on and so forth. Thank you for this question. Indeed, we thought about it, and one of our mission, it's a technical and the procedure model, how to keep track of the modifications. The first answer, we need to define the scope of elements, talking about the hull, that should be certified by the register and approved by the register. I'm talking about like minor equipment change. We will come up with a list. If this list is not modified, we are not going to go deeper into other pieces of the hull. This is our approach for time being. I hope that it answers your question. Thank you, colleagues. Do we have any other questions? Yes, we have time. Yeah, go on. I would like to do a follow-up on the previous question. There's an issue while we are switching from one 3D model format to another 3D model format, like triangles are used in one model and another system is used in another model, and the dimensions of the model change. As a measurement control representative, I saw several cases when we start checking the piece. We receive the model and we see one side of deviation. Then we see the second model reconverted from the first one. And we see that dimensions were shifted. And requirements sometimes are so tough, then those errors, they result in defaults. For sure, you discussed the question about the model of the format that should be as a standard one. And you should define that this model will be, this format should be used. I'm not ready to answer you directly this question. This question should be readdressed to my software developers colleagues. everyone asks this question, and we have the OCX format right now. We don't have a possibility to participate in this development and cooperate with them. But after your permission, I will forward this question to Nanosoft and to Ascon. They are better placed.
Откомментируйте,
пару
пожалуйста.
слов скажу. Первое, обращаю внимание,
Okay,
что буквально
let me draw your attention that 3 hours ago we signed an agreement between the register and us. And this is why we solved already several issues in terms of format compatibility. For 2 years, the construction register accepts bimodals, and we have experience because we made this mistake. We overcame it, so it's solvable. What about formats of stocking of files? In long-term format, we understand that the ship is the longest item to produce, and its life cycle is more than 50 years. This topic should be owned by the government. And we talked with the Ministry of Digitalization, with the archive, with the Ministry of Industry. We have some suggestions about the formats. So it's work in progress. Thank you for your explanation, and we are hitting our next program item. And I would like to give the floor to Alexander Petrov. You have the floor. Thank you. Thank you for allowing me the possibility to present. Yes, my name is Alexander. I'm director of the Department for the Development of Industry Solutions for the Shipbuilding. We work on SAPR and we work on the production block. A couple of words about ourselves. We have 1,300 specialists in the development consortium, the majority in the ASCOM company. All partners work to develop engineering software for different industries. We have major partners in academia, in education, of course, and the State Maritime Technical University is our partner number one. The technological basis for our job is the mathematical core. It's the only non-Western core, one of 5 cores globally. Have more than 60 clients domestically and internationally. Guys from NanoCAD talked about an important solution allowing reverse engineering, and they use the core that we've developed. The basis that we have is this mathematical core, the only one that is non-Western one. The work is being done not only on alternative Windows platforms and Linux, but also at Elbrus processors. So the import substitution is going on, and lots of things should be done. We have the roadmap of the project, the development of the 4th in the world of shipbuilding CIE system, and you can see major blocks here that will be developed by 2027. Inside you have a lot of subsystems. I'll talk about it a bit later, and the IT security, visual reality will be available. But here you have 10 blocks where the works are in progress. Let me brief you on what have been done already. We have a lot of blocks, and one block is a collective work on the project with a joint 3D model. Without this, it's not important to imagine a joint work over a ship, because large teams are working, several teams are working. This block will be presented to the second block is the block of the initial design. Many of you heard of the compass system, and here we have the frame grid. We have specific orders that allow to use necessary objects with the necessary tools. There are blocks that have been done already. There are blocks that are being prepared. As an example, we develop the block of cables, ventilations, pipelines. It can be used right now. Same applies to the plaza blocks for metal cutting. And I'd draw your attention that it's not a simple CAE system. Every necessary information is stored in the PLM system in order for the entire information to be gathered stage after stage and then transferred to the production.
Every month we have new teams, new functions, and new opportunities. So this is another function that simplifies the operation of different sectors. So this allows just to speed up the development of hulls. And you can also modify the hulls and redesign them. Another function allows to modify the structure. What's important? This particular software allows us to do calculations. It all starts with 1D module that allows us to calculate different components, and then we have the schematics here as well, then the 3D model, and then ultimately this SAPR module has a specific tool for statics, for the virtual basin, and electromagnetic calculations. All these calculations are going to be managed by an entire system. Therefore, we have the entire system engineering, but storing all the calculations in PDM. Well, so this is what I just wanted to say a few words about SAPR, and I'm very happy that we have a lot to do with Malakia, Kite, Rubin, Elmas, Vimpel, and other design bureaus. Next, I would like to say a few words about related systems. Last year, we cooperated very intensively with OKR Shipbuilding Company and were able to come up with the document with guidelines or regulations for digital manufacturing. This allows us to have an integral database, PLM and MES database that integrates all the SAPR parameters. This is just what Alexei said. We have all the information from SAPR downloaded into PLM, and the process is seamless. It is a continuous process. Here we can develop graphs, we can do planning, and all this data is saved in PLM. This is another template that is populated and fed in with information at every particular stage, and ultimately we come up with the production schedule. This allows us to provide this information to the top management via the web interface, and you can see how we move down the project stage by stage. You can also have all the information regarding the amount of work days, and we can also assign barcodes here, start or finalize the order, so on and so forth. The companies that are not into military technologies are rather into civil technologies, those can use mobile phones as well. Well, to be able to do control, we have also the necessary platforms. Today, we are already having the tools that are already there on the market. We have the mathematical core, the Gulfstream system, and other modules depending on particular task. What's important is that this is going to be an integral product that is going to cover the entire life cycle.
Будет решать существующие задачи как по размерам, количеству деталей, так и скорости работы. То есть закладываются
We would be able to resolve all the tasks for this module, and we are going to comply with
Поясню, что работа с судостроением нашего
all the challenges.
в частности, первый проект, крупный проект у нас начинался на полсе в марте.
I would like to say a few words about our background. We have been into that for many years already, and we extend our ultimate gratitude to Sevmash. For 17 years, we have been working continuously and unintermittently without any disruptions or impediment, and currently we have over 1,000 of enterprises that are using our solutions every day, and on top of that, we have other companies that are not into shipbuilding, but they also exploit our solutions. I would like to extend my gratitude to representatives of these companies if they are here for your feedback and for your reviews that allow us to move forward and advance forward.
Уже сейчас модуль корпусных конструкций можно использовать в работе, можно проектировать небольшие корабли.
I would like to share some of our projects. You could see the ships on the slide. Everyone is invited to our booth on the exhibition, the Ascona booth. Please, while you're thinking about questions, I would like to demonstrate how we can integrate the system, how it all works as a one bundle. If you have questions, please, those are welcome. Colleagues, do you have questions?
Пожалуйста, вот там рука.
Yes, please. I see there is one hand wishing to ask a question. Hello. I'm Vyacheslav Wellbook Company. Well, production is a lot more than just graphs and solutions. It is also welding, it is accesses and licenses for the workers, and lots of other things. Well, currently, our production module is under agreement, and we have specific modules for welding, and we are inviting partners to participate. I cannot say more details about the welding module, but we do have such tools, assure me. I take my word for that. More questions, colleagues? Yes, please. Thank you. Alexei, Neva Technology. You mentioned the welding module. Where are you going to get the information? Well, I'm not an expert regarding welding, and I regrettably cannot tell more information to you about the welding arcs and welding formations. So come to our booth and you'll get more information from our experts. If there are no questions, well, considering that we are creating just a very heavy weight, heavy load design software made in Russia, I believe that everything that is going to be there would be in the final software, something that won't get there. And if you do not communicate the information to us, we won't be able to include your module that you would like to have in the software. Yes, we are having lengthy negotiations with different design companies, and so please provide your feedback, provide any your ideas on what you would like to have in your modules. Thank you, Alexander, and we are moving over to the last presentation today, according to our agenda. Maxim Yarkov, senior expert of the Russian Maritime Register. Colleagues, hello, good afternoon. I'm gonna be short, considering that I'm the last one. I'm gonna show you some exciting pictures. Well, the methods to get a unit of a particular shape. There's a formative synthesis, meaning that we've got a bulk of material and we just change its shape without any losses. This can be extrusion, for example, or forming. The other method is subtractive synthesis. This means actually deduction. When we have some particular bulk of material and we cut what we don't need actually by some mechanical treatment or by cutting. And additive synthesis. This is a very fashionable kind of approach that has been there for over 10 years or probably even more. This means that we combine different layers, and thus we increase the mass and the volume of an item. What is more effective and efficient? I mean, what's more cost efficient? Where such integral synthesis can be efficient? Well, naturally it is efficient when we have to manufacture items of a very complicated shape with internal cavities or channels or spliced shapes or curved surfaces. So what are the technical advantages? Complicated shapes, internal cavities, for example, specific alloys. Hereby, I mean that we can produce an item of different alloys. For example, you start with one alloy, but then you change the composition of the material, and you can change its chemical composition. For example, the bottom of an item can be very rigid and resilient, whereas the top of it can have anti-corrosive properties. And the third advantage is the last thing is accrual. When you have some specific items, and the ultimate shape of the item is going to be very complicated, and it's easier for you to extend, to splice or augment this item rather than just cut it en bloc from one piece of material. Here you can see that we use a nozzle and a powder is applied. The laser is focused on the surface, and the powder that is applied to the surface is baked to the surface. And thus we kind of grow the item. The next principle is SLM, selective laser melting. The item is in the basin, it is in powder, and the laser focuses on the surface of the item, and melt the powder, which is baked to, which adheres to the surface. DMD method is more productive. It is more convenient to use if you have, for example, costly materials. As for SLM, the quality of the surface is better and the precision is better. So here you can see two examples of what additive technologies allow us to manufacture. To the left, you can see the fan by Ramblab. You can see the bolt, and you see that the fans were constructed layer by layer, and thus we have this specific item. They were able to manufacture this propeller in 3 days. To the right, you can see another example of a combined method. You can see the worm feeder here, and you know how much time would it take to manufacture this worm feeder from just a bulk of material. So these are ready-made items. To the left, you can see the propeller. It is already installed on the vessel, and it's navigating somewhere. And another item by the Ramblab company. Here you can see that it is a bowler, and again it was less cost efficient to manufacture it than manufacturing it from one integral bulk of material. And you can see how the powder is applied from the nozzle. That's just like a powder. The size of a grain is 1 micrometer, and it allows us to achieve a relatively high quality of the surface. And here you can see the wire. This wire is very well familiar to all of you. It is a welding wire. It allows to achieve better resilience and robustness of the material. What are the disadvantages of additive material? Whatever the method we use, the surface of additive material is always going to be up to 200 micrometers thickness, and it's going to be porous and different kinds of melting defects. Multiple defects in the body of an item can also be possible. Low but stable parameters of resilience. For example, steel may have different regions from 50 to 150 joules, whereas additive material may have 40 joules, but this value is very stable. And this also somewhat not a flip side, but an advantage. As for resilience, well, additive materials, whatever the technology, has numerous micro defects inside that concentrate stress, and therefore fissures arise, and the part is wasted. It breaks. Recently, we suggested to use less aggressive additive treatment. Well, as for normative documents, here I would like to say the following. If there are normative documents for steel, for packaging, And if the normative of these regulations are followed, no matter where you are, meaning that no matter where you are, you come up with the same chemical composition of the solutions, then you are going to have items of comparable or identical quality at the end. Whereas additive is every time requires some kind of creativity and art on behalf of the technology engineer. Therefore, regrettably, we do not have any regulatory database for additives. It is impossible to develop such a database. If a shipyard would like to copy some kind of would like to order some kind of additive detail or spare part, then they would have to provide entire specifications for this particular detail. And actually, designers would have to just reinvent this particular spare parts. And ultimately, I would like to say about the anisotropy of properties. When the item is being grown beneath, the heat is removed better than in upper layers. Therefore, the quality of the item may be different depending on a particular layer. And moreover, properties may be different across different axes. And this is due to just physical laws and the structure of the metal that is used to manufacture items.
The Register published a big chapter several years ago, and last year it has updated it quite heavily in terms of the materials to be used while constructing sea ships. Skolkovo and Prometei worked on it as well. The requirements are very clear and balanced. They are applied to the producer of the material and to the materials, to the sampling. Very interesting and specific nuances where the sample should be taken in order to be sure that the properties of the entire item really reflects the material. What? The manufacturer of the additive material should be certified by the register. It should prove the experience, the knowledge, and the skills to manufacture. Second, the register abandoned the technical survey for the manufacturing of precursors. Precursors are powders and other raw materials that are used for the manufacturing. So the manufacturer itself, the control of the manufacturer itself is fair enough. And there's rules about the labeling and general rules applicable to all materials that are used for shipbuilding. This concludes my part, and I'm ready to take your questions. Thank you, Maxim. Do we have any questions, colleagues? I don't see any questions. Let me add something on top of that. When several years ago the DMT technology has been introduced, yes, we have a Russian term, direct laser growth. And it's a bit different from something that was suggested by Optimiak quite a long while ago. This is the first thing. Second thing that relates to when we need to use additive technology. It's a question of cost efficiency because additive technology is expensive. The DMT is expensive, SLM is very expensive. how to evaluate. We need to solve for 1 kilo of the item. 1 item of stainless steel should be 10K rubles, and 1 kilo of an item manufactured by SLM is 5 times more expensive because the powder is much smaller and thus more expensive. If someone is afraid of the check procedure in the register, it's a simple check of a metal item. You need to bend, you try to rupture, you need to have a fissure, all the same. Since it's not reflected directly in the rules, but it was rightfully mentioned by Maxime, in case of additive production, it's not only the function of the composition, it depends on the geometry of the item and the process parameters. So for one complicated items, you need to do samples for every primitive part. It should be taken into account for sure. Wrapping up, I would like to say that our industry is unfortunately far from being the champion of the introduction of additive technologies. Our items are flying or is used at the items that doesn't live long. But we don't use it in shipbuilding, so I urge you to more actively use modern technologies. They may be of use, specifically if you have a small series and you don't need any accessories, and you can manufacture something 10 times faster versus the conventional approach. Maxim Schneck showed we have a very similar items that are procured by the USC for 350K. In case of using additive technology, the cost is 20K. So thank you for the register for the rules and regulations. No more questions? Yes, we have one question, and I was talking about the screws or the augers. Hello, my name is Ilya Fedorov. NEMA, Electromontage Company. What do you think? Your technology, maybe you had the experience during the ship repair, not ship construction, when I need to print a new item. Is it possible to apply this? It's not only possible to apply this. At one plant, we used it because we didn't know the access that we used at the ships. Ships are old, and they need to restore them in place, like the same approach. So like a barrage. Yes, the maritime register even certified the billows after the axles, after their repair. And you didn't mention arc growth. The arc growth is prominent as well. Dutch guys did that. It's not SLM, it's not DMD. If you want to see a domestic project of this kind, go to the F Pavilion at our university's booth. Everything that they can do internationally, we can do here domestically. It's not true that we have only foreign international products. Other questions, colleagues? Seeing none, thank you very much for your participation. It was very interesting. And in digitalization, we run into the same direction, which proves that this direction is correct. And comparing us with our foreign partners, they are moving in the very same direction. And we are not too much lagging behind, which is a rare case. And I hope that we will keep the velocity and we will maintain the efforts to create the very first 100% digital shipyard to appear in Russia, and that's our so we could be proud of it, should we do it. And I'm very pleased to know that the USC thinks about, yes, Khabarovsk shipyard is a wise choice. It's a small shipyard that won't be a technological breakthrough if you want to transmit this digital shipyard from Onega to a shipyard of a small size rather than to go to the big shipyard in one step. For us as a university, we are preparing experts for this digital transformation. The digital transformation is starting, but we already train youngsters. Maybe the curriculum is not exactly as it should be, but it stays a livable creature. And at this optimistic note, I would like to thank our speakers, I would like to thank the audience, and I hope that we keep meeting each other more often and the content will be even more interesting. This concludes the conference.